When sizing a double neutral, there are different approaches. One involves sizing the neutral based on twice the overcurrent protection. The other option is to size it based on twice the phase wire ampacity. Let's examine an example. Consider a 100 amp panel board feeder using number 2 American wire gauge phase wires. One approach would use a 3/0 American wire gauge neutral calculated as 2 times 100 amps equals 200 amps at 75 degrees Celsius. Alternatively, one could use a 4/0 American wire gauge neutral based on 2 times 115 amps equals 230 amps wire ampacity. An informal poll revealed that the majority sized the neutral based on twice the overcurrent protection. Specifically, 75.6% of respondents favored this method. A minority sized the neutral based on twice the phase wire ampacity, representing 24.4% of respondents. Based on the informal poll, most prefer to size the double neutral based on twice the overcurrent protection. However, both methods are considered sufficient by code. Now, let's consider additional factors. The National Electrical Code does not specifically require a double neutral to be sized based on twice the overcurrent protection or twice the phase wire ampacity. However, Section 215.2(a)(3) of the NEC states that the neutral conductor must have an ampacity that is not less than the maximum net calculated load current for all ungrounded conductors connected to that neutral conductor. Sizing the neutral based on twice the overcurrent protection ensures that the neutral can handle potential overloads. Sizing the neutral based on twice the phase wire ampacity provides a slightly more conservative approach, allowing for potential future load increases. The NEC mandates that the neutral conductor's ampacity should be at least equal to the maximum net calculated load current for all ungrounded conductors connected to that neutral. This ensures the neutral can safely carry the anticipated current. The decision on which method to use depends on the specific application and local regulations. Always consult the NEC and local electrical codes to ensure compliance. Firstly, consider the calculated load. This is the anticipated amount of current the circuit will carry under normal operating conditions. The neutral conductor must be sized to handle this load. Secondly, evaluate potential future load increases. If there is a possibility that the load in the circuit will increase in the future, it may be prudent to size the neutral conductor based on twice the phase wire ampacity. This provides a safety margin and ensures that the neutral can handle the increased load. Thirdly, examine the type of load. Nonlinear loads, such as those found in electronic devices, can generate harmonic currents that flow in the neutral conductor. These harmonic currents can increase the load on the neutral and may require a larger conductor size. Fourthly, consider voltage drop. A voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction. The size of the neutral conductor can affect voltage drop. A larger conductor size will reduce voltage drop. Fifthly, review local regulations. Local electrical codes may have specific requirements for the size of neutral conductors. Always consult local codes to ensure compliance. To reiterate, sizing based on twice the overcurrent protection aims to safeguard against overloads, while sizing based on twice the phase wire ampacity offers a more conservative approach for future load expansion. The most important consideration is always adhering to the National Electrical Code and local regulations to ensure a safe and compliant electrical installation. Remember that the neutral conductor plays a critical role in an electrical system. It provides a return path for current and helps to maintain a stable voltage. Properly sizing the neutral conductor is essential for safety and performance. The NEC provides guidance on how to size neutral conductors for various applications. The NEC specifies different rules for sizing neutral conductors depending on the type of load and the wiring method. Consult the NEC for specific requirements. The overcurrent protection device, such as a circuit breaker or fuse, is designed to protect the circuit from overloads and short circuits. The overcurrent protection device should be sized to protect the smallest wire in the circuit. The ampacity of a wire is the maximum amount of current that the wire can safely carry. The ampacity of a wire depends on the size of the wire, the type of insulation, and the ambient temperature. The NEC provides tables that list the ampacity of different types of wires. When sizing a neutral conductor, it is important to consider the potential for unbalanced loads. An unbalanced load occurs when the current in one phase of a three-phase system is different from the current in the other phases. Unbalanced loads can cause excessive current to flow in the neutral conductor. The NEC provides rules for sizing neutral conductors in systems with unbalanced loads. In some cases, it may be necessary to increase the size of the neutral conductor to accommodate the unbalanced load. In addition to the NEC, local electrical codes may have specific requirements for the size of neutral conductors. Always consult local codes to ensure compliance. When in doubt, it is always best to consult with a qualified electrician. A qualified electrician can help you to determine the appropriate size of neutral conductor for your specific application. The neutral conductor is an essential part of an electrical system. It is important to properly size the neutral conductor to ensure safety and performance. When sizing a double neutral, consider the calculated load, potential future load increases, the type of load, voltage drop, and local regulations. Always consult the NEC and local electrical codes to ensure compliance. The NEC provides specific guidance on how to size neutral conductors for various applications, taking into account factors like load type and wiring methods. Remember to consider the potential for unbalanced loads, which can cause excessive current in the neutral conductor, necessitating an increase in its size. Always consult with a qualified electrician to determine the appropriate neutral conductor size for your specific needs, ensuring a safe and compliant electrical installation. The neutral conductor serves as the return path for current and helps maintain voltage stability, making proper sizing crucial for overall system safety and performance. When selecting the appropriate size for a neutral conductor, one must carefully evaluate several key parameters. Firstly, the anticipated load is a fundamental consideration. This encompasses the aggregate current expected to flow under typical operating conditions. The selected neutral conductor must possess the capacity to handle this current load safely and efficiently. Secondly, the possibility of future load increases should be factored into the decision-making process. If there is a reasonable expectation that the electrical demands on the circuit will rise in the future, it is prudent to opt for a slightly larger neutral conductor to accommodate the anticipated growth. Thirdly, the type of load connected to the circuit is a significant determinant. Nonlinear loads, such as those associated with electronic devices and certain types of lighting, introduce harmonic currents into the electrical system. These harmonic currents can circulate within the neutral conductor, potentially increasing its thermal burden. Consequently, special attention must be paid to the sizing of the neutral conductor when dealing with nonlinear loads. Fourthly, voltage drop considerations come into play. Voltage drop refers to the reduction in voltage along the length of a conductor due to its inherent impedance. Excessive voltage drop can impair the performance of connected equipment and lead to operational inefficiencies. The size of the neutral conductor can influence the magnitude of voltage drop. A larger conductor cross-sectional area generally results in lower voltage drop. Fifthly, adherence to local regulations and electrical codes is paramount. Local jurisdictions often have specific requirements pertaining to the sizing of neutral conductors. It is imperative to consult and comply with these local regulations to ensure the safety and legality of the electrical installation. The National Electrical Code (NEC) serves as a widely adopted set of standards for electrical installation. It provides comprehensive guidelines on various aspects of electrical design, including the sizing of neutral conductors. The NEC outlines different approaches to neutral conductor sizing depending on the specific application and the characteristics of the electrical system. The NEC mandates that the neutral conductor must have sufficient ampacity to carry the maximum unbalanced load connected to it. The unbalanced load represents the difference in current between the phase conductors in a multi-wire circuit. In some instances, the NEC permits the use of a reduced-size neutral conductor, provided that certain conditions are met. These conditions typically involve limiting the amount of harmonic current present in a neutral conductor and ensuring that the neutral conductor is adequately protected against overcurrent. In situations where nonlinear loads are prevalent, the NEC may require the use of an oversized neutral conductor to mitigate the effects of harmonic currents. It is crucial to consult the relevant sections of the NEC to determine the specific requirements for neutral conductor sizing in any given electrical installation. Furthermore, it is essential to maintain accurate documentation of all electrical calculations and design decisions. This documentation serves as a valuable reference for future maintenance, modifications, and inspections. Engaging the services of a qualified electrical engineer or licensed electrician is highly recommended, particularly for complex electrical installations or when uncertainties arise regarding neutral conductor sizing. These professionals possess the expertise and knowledge to ensure that the electrical system is designed and installed in accordance with applicable codes and standards. In summary, the proper sizing of neutral conductors is a critical aspect of electrical system design. It requires careful consideration of several factors, including the anticipated load, potential future load increases, the type of load, voltage drop, and local regulations. Adherence to the NEC and consultation with qualified professionals are essential to ensure the safety, reliability, and compliance of the electrical installation.